have a look at the properties of variance. So as you remember, variance is just sigma squared, and we can either write it as sigma squared, or variance of x can be written down in the following way. So as we learned previously, variance of x can be found by finding the expected value of x minus the mean squared. And I will now give a small proof for that. So if you think you know this, you can skip ahead of this, I suppose. So originally we said that standard deviation can be found by finding the sum of x minus the mean value squared and dividing by the total number of values and finding the square root. So first of all, we need to understand that the square root disappears because we just square the variance. But then what happens next? So now we have this. So what we realized is that instead of dividing by the total number of frequencies, we could multiply with probability. So we could actually say that we find the sum of x minus the mean squared. Oh, the square should be here from the very beginning. Multiplied with the probability. And now if we think about this, as we can see it, we have the expected values defined as a sum of x values multiplied with the probabilities. And actually that is exactly what we have here. Only instead of just x, we now have the x minus its mean value. So instead of just having expected value of x, we will have expected value of x minus its mean value squared. But as we know, the mean value is mu, so the formula actually becomes expected value of x minus mu squared. So this is the definition of the variance. Variance can be written as expected value of x minus mean squared. There are several properties. First says that variance can also be written as expected value of x squared minus expected value of x, which is then squared. And just because it's very short and simple proof, let us have a look at why does that work out to be true. So if we start with the one that was given on top here, we can expand the brackets and we get x squared minus 2x mean plus mean squared. Now, using the properties of expected values, we can take the expected value of each of those parts separately. So we have this, if you follow through, an expected value of mean squared is just mean squared because mean is a value, not a random variable anymore. But we know that the expected value here is equal to the mean, so we actually end up having expected value of x squared minus 2 mean squared plus mean squared, which then simplifies to expected value of x squared minus mean squared. And as you know, mean squared could be written as expected value of x, which is then squared. So that's the proof of it. That's our first property. The second one is that variance of any constant c is always 0. Variance really shows us the distance between the point and the average, but there is no distance as such because we're only looking at one value c. And the last one is that variance of a linear combination cx plus d can be written as c squared variance of x. And you can see the proof of that in your book. It's actually not that difficult, but we looked at that in class already, so I'm not repeating that here. So those were the three most important properties of variance. The first, variance can be written in the following form. Second, variance of a constant is 0. And variance of a linear combination of x can be written as c squared variance of x.